Sizing of solar battery. In this session, we're going to be talk about how we can size the solar battery for designing process of the solar home systems for the 300 watt capacity over here. So basically we know the watt hour consumption for the consumer on the daily basis is 1110 watt hour over here actually. So this watt hour capacity will required whenever we are sizing the battery bank capacity for the consumer actually. So for that purpose, we can use the formula that the total capacity of the battery bank is equal to the total power consumption of a consumer in terms of the watt hour on the daily basis multiplied by the number of days of autonomy that will required by the consumer in a bracket divided by the system voltage multiplied by the percentage of the depth of discharge for the battery. So in this case, the number of days of autonomy is called as how many days actually the consumer want the safety storage of the power over here actually. In some cases, in some rural areas or in the remote areas actually, where the grid is not been available for most of the days, so that time the consumer require the battery autonomy for the 2 days up to 3 days or the 4 days also they will required over here. So in that cases, is number of days of autonomy we can decide according to the situation and according to the consumer demand also we can select actually. In this case study, we can select only the 1 day of the autonomy for the battery bank storage over here. Next is the system voltage. System voltage is also called as the battery bank voltage over here actually. So basically how much amount of a battery bank we are deciding, how much amount of the voltage that we are feeding to the solar charge controller, what is the rating of the solar charge controller, and what amount of the battery bank rating we have to be selected when we are joining the connections of the battery. So in this case, we are feeding to the voltage of 17.47 volt near about voltage to the charge controller. We have selected the rated voltage of the solar charge controller as an 12 volt over here. So whenever we do the battery bank connection, that should be the 12 volt of the battery we have to be select over here. So in that cases, our system voltage is our 12 volt. So the battery will going to charge by the 12 volt of the solar charge controller. Whatever the battery will going to use, that is also the 12 volt battery we have to use. Whatever the current or voltage that we are feeding to the charge controller, that is also close to the 12 volt that we can feed it over here actually in this case. So that is why the battery bank voltage we can take it over here as a system voltage over here. So we are taking this voltage as an 12 volt multiplied by the percentage depth of discharge. Up to how many percentage we have to utilize the battery power from the battery actually, that we have to decide in the percentage depth of discharge. In most of the cases, the lead acid battery will have the percentage depth of discharge of the 50%. That is up to the 50% we can utilize the power from the battery. Once the 50% power has been utilized, we just cut the supply from the battery over here and we wait for the sun's radiation if it is a off-grid type of the solar project. If it is an on-grid type or hybrid type of a solar project, we take a power from the grid to charge the battery once it is reached up to the 50% of the depth of discharge. So if we have to utilize up to the 90% of the depth of discharge, it means what? Up to the 90% if we are utilizing the power, only the 10% has been remaining. So we can say the battery is approaching towards the dead condition over here actually. So that is why up to the 90% of the power from the battery that will going to be utilized for our consumption. So most of the cases in the rural areas where the grid has not been available actually, so that time 90% of a depth of discharge of a battery we can take it over there actually. But in the most of the cases, whenever we'll have a frequent grid is been available, so we can go for the 50% of the depth of discharge also. So in this case, we just taking as a 90% of a depth of discharge, and now we can do the calculation over here. So 1110 watt into the 1 days of autonomy divided by the 12 volt system volt multiplied by the 90% of depth of discharge. So we are getting the answer as a total capacity of a battery bank will be the 102.77 ampere hour as per the consumption of the consumer has been concerned. So close to this rating of a battery actually, whatever the rating, standard rating of the market standard has been available, so that we can choose it over here. So in the market, the 100 ampere hour battery is easily been available, which is a 12 volt rated volt will be there, and the 100 ampere hour is the storage of a battery will be there actually. Now once we have selected the battery, we have to check that how many numbers of the battery we require to be connect in the series combination and how many numbers of the battery will require to be connect in the parallel combination. So first we'll see how many number of a battery to be connected in the series combination. The formula is the battery bank voltage divided by the voltage of individual battery. So our battery bank voltage or the system voltage is our 12 volt divided by the individual voltage of a battery what we are selecting, it is a 12 volt also. In the market the 6 volt batteries are also available, that also we can use it over here actually. Second thing is that the number of a battery in the series combination after doing this calculation is number 1 over here. So total 1 number of a battery will require to be connected in the series combination. Next is the number of a battery to be connected in the parallel combination. So in the parallel combination, the total capacity of a battery bank divided by the capacity of the individual battery what we have selected. So in this case, the total capacity of a battery bank as per the calculation, it is 102.77 ampere hour will required divided by what individual battery we have selected from the market, which is 100 ampere hour. So we just do this calculation, we are getting the answer as an 1.027, which is close to 1 over here. So the one number of a battery we can connect in the parallel combination over here. So once we know how many number of a battery we can connect in the parallel and the series combination, so we can calculate the total number of a battery required to be purchased or required to be connected over here as an number of a battery in the parallel configuration multiplied by number of a batteries in the series configuration. So we have a one number of a battery in parallel as per calculation, one number of a battery in series. So the total number of a batteries are required are only one over here. So this battery can satisfy the needs of the consumer corresponding case and the corresponding requirement of the hours over here actually. So for that purpose, we can go for the luminous battery of a 100 ampere hour, which is a 12 volt rated voltage battery will be there. So now we're going to select actually, or now we're going to draw the circuit diagram of the connections over here. So in the small capacity of the solar home system, which is running on the DC load system actually. So in that cases, the 3 solar panels we have connected over here. So the power output from the solar panel that we can give to the solar charge controller. In between that, we can just attach one MCB fuse over here actually. So either we can go for the fuse or rather we can go for the miniature circuit breaker. So basically the role of a miniature circuit breaker is that whenever any excess amount of the current is passing as per the requirement, this will going to trip in this situation over here actually, and it will going to safeguard our solar charge controller. So while we just going to join the solar panels to the charge controller, in between that we can go for the one MCB switches over here, or the fuse also we can utilize over here actually for the saving the cost purpose. Then we give connections to the PV panel over here. So it has been written over here, the PV positive and the PV negative over here over this corresponding charge controller. So basically as per the day conditions and the radiation condition, though we have a standard maximum power point voltage is 17.47 volt over here, but in the morning situation this will going to feed near about the 10 volt. Again in the afternoon it will going to feed near about the 15 volt. Near about the 1 to 2 p.m. in the afternoon it will going to feed near about 17.47. Again in the evening it will going to feed the 12 volt. So like that there is a variable form of the DC voltage that we are giving to the solar charge controller actually. In a solar charge controller, it is converting the variable form of the DC voltage into the stable form of the DC voltage over here actually. That is the main functionality of the solar charge controller, why we are just directly connecting the panels to the controller over here. So whatever amount of the voltage that we are feeding to the controller, it will going to convert this voltage into the standard rated voltage of the 12 volt over here. This 12 volt is required to charge the battery over here actually. Then we take a battery over here, which is our 100 ampere hour battery we are selecting, which is a 12 volt rated battery we have selected. We give the positive connections to this controller, we give the negative connections to the controller. This is a B positive and this is a B negative over here. And the third terminal is our socket terminal. So from this we can take out the DC power and we can utilize this power for the corresponding equipment over here. So we can just take out the power in the one main DC socket and here the number of pins has been available over here. So we can give one pin to the DC tube light, we can give other to the LED light, and we can give other to the DC fans over here actually. So like that we can just utilize the designing of the solar power system actually with the help of the solar charge controller over here actually. So in this case we attach the panel also, we attach the battery also, and we take out the power in terms of the DC format also over here.